Okay, today we're going to study 1.7, and 1.7 we're going to look at solving absolute value equations and inequalities. So we've talked about regular, linear equations and inequalities. Today we're going to put an absolute value in those. If I ask students to define what does absolute value mean, usually the answer is you just make numbers positive. Which for real numbers that totally works. You can just make the number positive. So the absolute value of 5 is 5. The absolute value of -3 is 3. And just make it positive and that works. But what absolute value really truly means is the distance away from 0 on a number line. Since distance is always a positive value, then in a sense we're just making it positive. Later this year when we get into chapter 5, it's going to be important that we think of absolute value though as not meaning just make it positive. Because we will have some types of numbers that doesn't work for. For our real numbers now, it works. So you can just always make it positive. But later, we're going to actually have to start thinking about absolute value as being a distance. We're going to solve 3 different kinds of problems today. The first kind of problem that we're going to solve is an absolute value equation. In an absolute value equation, there are 2 solutions. Because the inside could be equal to the positive number, or the inside could have been equal to the negative number, and then when we took the absolute value, it became positive. Okay? So we're going to get 2 solutions there. Then we're going to solve inequalities, and there's 2 different types of inequalities. A less than is going to create an and statement. A greater than is going to create an or statement. So we're going to have 3 different types of absolute value problems today. So we're going to start with equations. So before we even do this one, I want to do like a really basic one and just say, what if I had like absolute value of x equals 4? Solutions are any number that could work here. So we have to ask ourselves, well, what has an absolute value of 4? 4 has an absolute value of 4, but -4 also has an absolute value of 4. Okay? So when we solve an absolute value equation, what we need to do is say the inside stuff could have been 9. Or the inside stuff could have actually been -9, but then when I took the absolute value of it, it turned into just a 9. Okay? So we're going to solve absolute value equations by setting up the inside equal to the positive and the inside equal to the negative. It is tempting for students to just solve the problem once and then say your answer is the positive and negative version, like it was in that simple example that I started with. That's not always the case though. Okay? Sometimes it's the same number, just plus and minus. Sometimes it's just 2 totally different numbers. So it's important that you actually do both solving problems. So for the first one, I'm going to add 5 to both sides and divide by 2. And 7 would work in here. For the second one, I'm going to add 5 to both sides and divide by 2. And I find that -2 would also work in here. To confirm that they work, we can always, in an equation, take those back to the beginning and plug them in. So if I plug in a 7 to the original problem, 2 times 7 is 14, minus 5 is 9, absolute value of 9 is 9. If I plug in a -2, 2 times -2 is -4, minus 5 is -9, which is the absolute value of that, and I get a positive 9. So they do both work. Okay? And they're not just opposites of each other. We actually had to solve both of them individually. Okay? Questions?
So x could be 2 different numbers.
X could be either one of those numbers, and the statement would be true. So this is like an or answer. It could be one or it could be the other. It can't be both necessarily, at least not at the same time. But it could be one or it could be the other, and they both work. Okay. All right, so we set the inside equal to the positive, inside equal to the negative, and solve them both. Go ahead and try this one. So we begin by setting the inside of the absolute value equal to the positive, and set the inside of the absolute value equal to the negative. We solve the two equations individually. So in the first one, adding 3 gives 18, and dividing by 6 gives 3. And the second one, adding 3 gives negative 12, and dividing by 6 gives negative 2. So both of these values should work if they are plugged in for x in the original problem. Questions on absolute value equations? Okay. One more example over here. I think it's like number 7 on your sheet, but we'll just skip by that. So then this is an inequality. Again, I want to start with a more basic example than the one that's here. So I want to say, let's say the absolute value of x is less than 3. So if we think about absolute value as meaning distance from 0, what this says is the distance from 0 should be 3 or less. So if I think about graphing that out on a number line, I could be back at negative 3. I could be up at positive 3, and anything between them has a distance of 3 or less from 0. So a less than statement is going to be a between statement, or an and statement. So the way we set it up is we're going to take whatever the value is and put its opposite over on the left. I'm going to take that 11, I'm going to put it as a negative 11 over on the left. Then I'm going to use the same exact symbol. So since this is a less than, I'm going to use the less than. Drop out the absolute value, and then have the less than 11. Okay? So we're bordering our absolute value between the boundaries of the positive and negative version of the number. We then solve this. Yesterday we learned how to solve these between our and statements. I'm going to begin by subtracting 7 from all 3 parts of the inequality. So that gives me negative 18, 2x, and 4. And then I'm going to divide all parts by 2. Gives me negative 9, x, and 2. Yes, question?
Can you go over that first step again? How you put 11?
How we do our setup? Yep. So when it's a less than statement, what we're going to do is take whatever our value is in the problem. So in this one it's an 11, and I'm going to border that absolute value between 11 and its opposite, negative 11, and drop out the absolute value. Okay. So whatever that number is, I'm going to put its opposite or negative version over on the left-hand side. So this is our solution, and then whenever we have an inequality problem, your directions will ask you to graph the solution. So to graph this, we learned yesterday that we'll put the two numbers from the problem and 0 on a number line. There are no equal to bars here, so we're going to use open circles, and we want the numbers that are between them shaded. A less than absolute value inequality will turn into an and statement. Okay? Questions? Go ahead and try this one. Okay, so this is a less than statement. That's going to become our and or between statement. So I'm going to take that 21 and I'm going to put a negative 21 over on the left. Use the exact same symbol. So because it has an equal to bar, I'll use an equal to bar on the second symbol as well. Drop out the absolute values and then complete out the rest of the problem. To solve, I'm going to add 9 to all 3 parts. That gives me negative 12, 4x, and 30. And divide by 4. Gives me negative 3. X and 7.5, or 15 over 2. To graph, At -3, 0, 7.5 on the number line. Close circles because they had the equal to bar, and shade in between. So yesterday when we had these and statements, we said that sometimes one of them could be open and one of them could be closed, which if it's given to you that way, that's absolutely fine. But when you're creating it because of an absolute value, they should always be the same. Okay? So if one of them's open, the other one should be open as well. Questions on less than statements? I have one more example here. I think it's like number 8 on your sheet, but we're going to skip it. And that brings us to a greater than statement. So this is our third and final kind of problem for today. Once again, I want to start by looking at a more basic example and just say absolute value of x is greater than 4. So if we think about absolute value as meaning distance from 0, what this says is we want the numbers that are further away than 4 units from 0. So on a number line, if I want to be more than 4 spaces away, I have to be going outward on my graph. And we learned yesterday that when our graphs look like this, it's an OR statement. So this is going to turn into an OR statement. If you forget and you try to make this an AND statement, I'm going to do this in red because it's wrong and you probably don't even want to write it down unless you want to write it with a big X through it because this is wrong. But if you forget and you try to set this up as an AND statement, what you're going to get is put that opposite over on the other side, use the exact same symbol, and then I've got stuff in here, whatever the stuff happens to be. In this problem, it is what it is, but in general, there should be stuff in there. If I ignore that stuff, this problem says that -8 is greater than 8. That's not true. So we've just set up something that's false. Means that this is not going to lead us to a good answer. Okay? So if you forget which way and you try to start setting it up the way that we did the other problem, hopefully you'll realize that we have an issue here because we just said that -8 is bigger than 8. Okay? So these problems must be set up as OR statements. So we're going to set up 2 separate pieces. The first one will be the given problem, just drop out the absolute values. Then we're going to have OR. Our second one, we're going to use the same inside, but we're going to make 2 changes. We're going to flip the arrow and change the sign. So it becomes less than a negative. Okay. The first one, we just drop out the absolute values and leave everything else the way it is. In the second one, we make 2 changes, flip the sign, make it negative. And we learned yesterday that we solve our OR statements separately but graph together. So in the first one, I'm going to add 2 and divide by 3. 10/3 is not really a pretty decimal, so I'm just going to leave it as a fraction. In the second one, I add 2 and divide by 3. And our answer is putting those 2 solutions together with 4. Then graphing. One of them says it's a less than -2, so that goes to the left with a closed circle. And the other greater than 10/3 goes to the right with a closed circle for the equal to. Okay, so for an OR for a greater than statement, you're going to turn it into an OR by separating, leaving the first one just as is, the second one 2 changes, flip the arrow, make it negative. You can remember it by kind of thinking of a greater than as a way of saying you have more, and it turns into an OR. So our mores are ORs. Okay? Go ahead and try this one. Okay, so this one's a greater than. That's going to turn it into an OR statement. The first one, we just drop out the absolute values. And OR, for the second one, we drop out the absolute value and make two changes, flip the arrow, make it negative. Solve them individually, adding 2 to both sides of the first one. There's 20. Dividing by 3 is not a nice decimal and not reducible, so I'm just going to leave it. And the second one, adding 2 to both sides gives negative 16. And again, dividing by 3 is not reducible and not a nice decimal, so I'm just going to leave it. Then when we graph, we would put both of those on a number line, open circles, and they would end up with empty space between. So equations. We set the inside equal to the positive, inside equal to the negative. A less than, we set up strung together as an and, putting the negative number over on the left. A greater than, we make into an or statement. For the second one, flip the arrow, make it negative. Questions? I'm going to look at a special case before I set you on to your homework. So this will be your homework as printed on your sheet. Make sure you notice some multiples of 3 there so you don't end up doing way too many problems.
We do we get extra credit?
Nope, no extra credit for doing extra practice, but no extra credit. I want to say, let's say I have x plus 2 absolute value is greater than negative 4. Okay, so how would I solve this problem? It's a greater than, so what do I do with greater thans?
You do it twice on the second
Do it
time.
twice. Okay, so for greater than, we split it, and we make 2 changes on the second one, flip it, and then do the opposite. So now if I solve these, subtract 2 in the first one, I get x is greater than negative 6. Subtract 2 in the second one, and I get x is less than 2. If I graph these, negative 6, 0, 2. The first one says x is bigger than negative 6. That goes this way. The second one says x is smaller than 2. That goes this way. What happens? I have the whole number line. So what does that mean? Any number really works. So we talked about the other day how sometimes we could say we have all real solutions. Solutions. And we have that symbol that says this. Now why? Is there a way I could tell this just by looking at the very beginning problem without having to do any work for it? What do we know about an absolute value? What's always true about an absolute value? It makes everything positive. An absolute value is always positive. So this problem, looking at the very original statement, says an absolute value, which should always be positive, is bigger than negative 4. Yes, positives are always bigger than negative 4. So this statement right from the get-go, if we notice that, we could say it must be everything, because positives have to be bigger than a negative 4. So, what if I had absolute value of x plus 2 is less than negative 3? What do I know about an absolute value? It's always positive. So when is a positive number smaller than negative 3? It's not. Positive numbers are bigger than negative numbers, so this one has no solution to it. So watch out for those special cases. If you have an absolute value in your problem and it's starting out with a negative, you're probably going to have some kind of a special issue arise. Okay? All right, let's go ahead and begin on your homework.